Okay, so hope you will enjoy the session and all the very best and happy learning. Sharaf?
Yes, sir. Okay, thank
Yeah,
you. I will continue
give,
from here. Yeah,
yeah, give me a second. I will change it as host.
yeah. All right, guys. So wait a minute. I will share my screen. All right. So today we are going to talk about some basic things about programming, right? So I'm here to present like I'm not going to teach any programming language, right? So at the first time, like I need to like clarify about that. But so as a student of computer science and IT, software engineering, whatever it is, right? So when once you graduated, you will become a software developer, or you will go with the you will choose the database path, or you will go with the network, and so kind of things. Uh, so here I will like just introduce like how you can get into like programming, and what are the basic stuffs available there, and what are the things that you can focus on. So that will be the overall approach of this webinar, right? So in future we'll do more kind of these webinars, so you can get an idea of more interesting topics in the current trend. So so let me introduce myself. So I'm Sharaf Nazir. I'm working as a senior software engineer for a company called Just-in-Time Technologies, and I'm also a tech speaker and lecturer. And always you can contact me through these links provided here, right? So we'll quickly jump into the session. So programming. So don't think like this will be not kind of a lecturing session, right? Session should be an interactive one. So I'm not the one who is only going to speak here. So students who are available, or the audience also should be speaking, and you also should give your opinions and all, right? So I think all of you have like all of your background is from computer science or IT or software, isn't it?
Yeah, sir.
Okay, so I think most of you have might have this term called programming, right? So basically, programming is about like, so what we are doing is like we tell the computer, or we tell some machine, or basically it's a computer to do some set of tasks, right? So we provide some instructions, and the computer do the process, and it gives some meaningful output. So from the output we can do our more further research and further development stuff, right? So this programming, usually it is done by using a variety of computer programming languages, so that you are familiar with always. And so if you talk about these programming languages, so it is kind of a machine understandable language, right? So we give the instructions to the computer, some logic or something kind of a thing. So usually we call that as a code. So in any programming language, so like C or C++, Java, C Sharp, or anything, so we write codes on it. So those codes will be like converted into some things which the computers can understand. So that's how the computer programming works, right? So basically, if you talk about these programming languages, we have some set of programming language types, right? So basically, we can divide them into high level and low level languages. So these two languages will be like running on top of the hardware that we are pursuing these languages. Either it can be a computer or mobile phone or any other things, any other devices which understand machine languages, right? So the low level languages we can briefly divide them into two things like machine language, assembly languages, and if we talk about these high level language, it will be like object oriented and procedural languages. So if we go into the details, so if you talk about the low level languages as the very first stage, right? So there is a category called machine language, so which it directly runs on the CPU. So this type of languages is like a kind of like zeros and ones, right? So you might have seen this kind of a things like 1100. So this is called as bytes, or we can call it as like binary numbers. So this is what only the computer understands, right? So each whatever programming language or whatever code or whatever program we code, it will be always like converted into this format. So then only the machine will be understanding that one. So this is the one. So in the earlier stages, the programmers write to like they intended to write. This is how they were doing programming when they are doing some stuff, right? So and also this is like error prone. So we cannot trace the errors easily, and we have to do that. In order to do that, we need to do several process, right? And also zeros and ones, no one will understand. So everything is like zeros and ones, so it is not understandable. And also we cannot so since it's directly like it directly runs on CPU, we cannot look into that, and we cannot modify. Only the experts who knows these bit codes or these binary numbers are the persons who can override these things. So that was the very first language, which is called machine language, and then they introduced something called assembly language. So this is basically less error prone. So yeah, so this is basically the less error prone, right? So and what happens here is like, so earlier it was zeros and ones, but zeros and ones here in the machine language. But here in the assembly language, what they did was they come up with some English instructions instead of using ones and zeros. Like you can say, like you can see these ones. So like some instructions like add, divide. Likewise, they had some instructions which is more likely to be English. So those are English instructions, right? So it gives a feasibility to code the program. Compare it was like if we compare that one to the machine code or machine language. So using assembly language at that point, it was much easier compared to the machine languages. So that is the second point of programming languages, and then it comes to the high level languages, which we do now, right? So these are the languages that we like use in the current trend. Like it is portable, we can write it anywhere, and we can just plug it, right? We can do some modifications, we can see that one. So statements are likely, it is more likely to be English language, right? And also amount of abstraction provided defines level of programming languages. So like let's say if we talk about this machine language, so the person who is doing program using high level language, he does not need to worry about these ones and zeros, right? So he only cares about the code that he writes. He doesn't he anymore no need to like worry about these ones and zeros, because that is kind of an abstraction. So that was the feature introduced in the high level language. So anyone can write any program, right? So he uh, he's not like he don't need to like understand all the ones and zeros and all the processing stuffs which is happening in the CPU, right? So these are the languages that we currently use now, like Java, C Sharp, C++, and Python, even JavaScript, PHP, and other stuff like Ruby, and so on. There are like so many languages introduced now, and there are so many frameworks as well built on top of these languages, right? So, but further, we can divide this high-level languages into two different kind of subsets, like procedural languages and object-oriented programming languages, right? So in procedural programming, this one is basically it will be all the codes in the programming language. Sorry, in our code segment will be divided into small parts like functions, right? And the procedural programming, it follows some top-down approach. So it executes from the bottom, sorry, from the top, and it comes through the bottom. So it should execute from the top to the bottom. So it can't like execute. So if we have like a 5 code segments, something like this, right? Maybe. So if we have 5 code segments, something like this, so it needs to be executed one by one. So it needs to be executed in direction, right? So that is called a top-down approach. And there is no accessor specifier in procedural languages like private, public, and protected, those kind of things. And it is also less secure, right? And we cannot do function overloading and overriding, those kind of things. So these were like initially used languages under high-level languages such as like C, Fortran, Pascal, Basic, and there are other um, languages as well. But C is still, it is being used, and Fortran and Pascal, it is being used for the time moment. So C is used to be to do like programming in embedded systems and IoTs and those kind of things. Basically for machineries, C and Fortran, Pascal, those kind of things are being still used, right? And if we talk about this object-oriented programming, right? So it is all about objects and classes and all. So here in object-oriented programming, we divide the code into small chunks called objects, right? So, and also object-oriented programming is kind of a bottom-up approach. So we don't need to execute one by one, right? So wherever it is called, it can be executed. And also it has these specifiers like private, public, protected, and all. And we can have data and functions, and it is very simple to declare here. And it is more like secure compared to other programming types. And also we can do overloading. We will talk about this overloading in the later slides, right? When we talk about some OOP concepts and all. But for the moment, so these are the difference that and the object-oriented programming was like have, right? So for example, we can say like C++, Java, Python, and C Sharp, etc., right? So even like we can see some languages now, PHP and JavaScript, right? So if you talk about this PHP, so in the earlier stages, so the old versions of PHP was introduced as a procedural programming. Then they converted into they converted the new versions of PHP like PHP 8 and PHP 7, those kind of things, right? So it was converted to object-oriented programming. So the same thing applies for JavaScript as well. So earlier it was like procedural, and then they moved, we can do OOP in JavaScript as well, right? So those are some different categories which comes under high level programming languages. And so here we talk about this machine code. So this machine code is the only one which our computer can understand, right? So if we, in that case, so if we talk about this high level language, so there is should be a mechanism, right? So there should be a mechanism where we need to convert this high level language into this machine language. So then only the computer will understand. So as I mentioned before, the computer only understands ones and zeros. It only understands that 2 bits, right? Zeros and ones. So nothing more than that. So if that is the case, so here we are saying statements are like English language. How the computer is going to understand the English? So that's a problem. So then in like to convert this high level language into machine language, what happens was, so they introduced something called compilers and interpreters, right? So these two are different things. So compiler and interpreter, it has its own process, right? So what compiler do is, so a compiler, it always, it will be like transforming our written code. For example, if you take Java, right? So if you are writing some Java code, what happens is it will convert that Java code into a machine code at once, right? So before running the program, right? So let's say we wrote a calculator program, right? A simple program to add 2 numbers or something, right? So before running that program, what happens is the compiler transform all the codes into an intermediate code, and that intermediate code will be transformed to a machine code, right? So that's how the compiler works. The compiler will run before the program runs. So that is the startup point. So after compiler, then only if the compiler will check the errors and the syntax errors and all. So if it is everything is like perfect, only the program will intend to be run. It will be start after that, right? But in case of interpreter, right? So what happens is it converts the high level program, right? So let's say we have 5 set of statements in our program, right? So it will convert one by one. So for each and every steps, so the interpreter will convert each and every steps one by one into the machine code. So this will happen when the program runs, not before the program. So the compiler will run before the program begin, but the interpreter will do the interpretation when the program is running, right? And the compiler always it is faster than interpreter, and also a compiler is possible to display all the errors after compilation, right? But the interpreter will only displays errors like one by one. It won't display errors at a one point. And compiler is based on translating linking loading model, whereas interpreter is based on interpretation method. So this is what I mentioned. So link loading method means like it will be translate the whole code segment into a machine code, or it will transfer it into an intermediate code, and that intermediate code will be transferred into some machine code. So that's happening in compiler. But interpreter, it has its own interpretation method. So based on that interpretation method, it will one by one interpret the statement. And compiler takes an entire program, where the interpreter takes a single line of code. So that's what I talked before, right?
So excuse me, sir.
Yeah,
So nowadays we are using interpreter or compiler.
we are using both. So if you talk
We are
about
using both.
Java, right, it is compiler. So we are using compiler. But if you are talking about Python, PHP, even JavaScript, that is based on interpreter, right? So what happens is like when you compile Java code. So are you familiar with Java?
Yeah, sir.
Okay, so if you compile Java, you will get the class file out of that, right? So let's say you have a
Yeah, sir.
student.java file. So you will get a student.class file. So you cannot read that file. That's kind of a read-only file. If you open that one, there will be some codes which you cannot understand. So have you seen it that before?
No, sir.
So let's say student. Okay, we'll check that one. Give me a second. So okay, let's assume this is your Java file. So when you compile this one, right, you will get another file named with developer.class. Have you seen that one? Something like
Yeah,
this.
yeah, sir. Yeah,
Something
seen
like
that.
this. So so that is the intermediate code that I'm talking. So you cannot read this one actually. This output
Okay.
files, you cannot read this one actually, right? So
Okay, sir.
right, so that is called compilation. So that class or the file or Java file or C# file, so C# it behaves differently. That there it will be creating DLLs. Here we are creating .class files in Java, right? So that depends on the program, it depends on the language that we are choosing, right? So, but remember, this compiler will transform our code into a machine code at a once, right? But if you are talking about PHP or JavaScript, so it doesn't output any class files or DLLs or something else like that. It just runs. If you open the browser, it will run, right? If there is an error, it will denote. So that is basically interpretation. We don't have a, so those are the two things which we can convert our high level languages into machine code, right? Right. So this is some visualization of compiler and interpreter. So source code, when we do the interpretation, it gives the output directly. But for the compiler, so source code should be compiled and it will converted to machine code and it will be output after that one. So basically that's how the compiler and interpreter works, right? All right. So that is kind of some introduction about programming. So how these languages are classified and how the interpretation and compilations is doing. And the next section will discuss something about language comparison. So I have chosen like some languages you might be familiar, something you might be not familiar about. But anyway, so I have chosen like C++, Java, C#, and PHP, right? So here we can use this kind of data types. So in C++, if we are talking about integers, there are like different data types: short, unsigned short, integer, and unsigned integer, and long, unsigned long, and all. But in Java, we have only like byte, short, int, long, and where in C# we have this byte, short, integer, integer, long, and so many things. And in PHP, we have this integer, that means the int, right? So here, if we talk about these floating point numbers, right? So this C#, it has like float double and float double here as well. But in C#, it has, that is C++. For C#, we have additional thing called decimal. And in PHP, we don't have that thing. So floating point numbers are denoted as float. But you need to remember one thing. I will talk about this later as well, right? So C++, Java, and C#. So it is like static. We need to provide these data types as in a static way. We need to provide like for example, if you are declaring an integer variable in Java, we need to denote that as int number 1 equal to 10 or something else. So same applies for this C# and C++ as well. But for PHP, we don't need to define that. We don't need to define that data type actually. So we will look that one later, right? So this is kind of a thing like char we have, and in the PHP we don't have anything normal thing called char. We have strings there, right? Character and white character, and we have booleans. Usually in C++ we use it as a bool, and in C# also we use it as bool, and in Java we denote that as a boolean, right? So that is basically true or false values. Then so this is what I mentioned before. So if we are declaring some variables like in Java, we do it like this: int a equal to 0, and this is something similar to C# as well. So you can see the code differences, right? So there's no much difference in variable declaration in Java and C#. So it is both are same. And for C++, we have something, the same thing we can have, and also we can define B like something like this. So this will like another add-on to this B variable, right? And in PHP, so this is the two difference. So for other languages and PHP, right? So this is called static typing, and this is called dynamic typing. So static typing means we definitely need to provide the data type. So whether into string or boolean or something else, we definitely need to provide this data type. So here you can see this one is int, and this one is int, and this one is int, and same as this, right? But for PHP, it's like a dynamic type. So let's say this is how we declare a variable in PHP. So if we equal this one to an integer, so we know this 50 is an integer. So this a variable will be treated as an integer variable, right? So if we remove this 50 and if we provide some string, something like this, so we provide some string, maybe A, B, C, right?
So PHP is somewhat like Python, right?
Yeah, same thing. So PHP also use interpretation, not the compilation, right? So if you provide this one, so this variable A will be now treated as what do you call a string variable, right? So this is called dynamic type. So this one is like static, and this is dynamic. We don't need to provide any data types because PHP it does not support that typing, right? Same applies for what do you call Python and even JavaScript, right? So you don't need to declare like int or float or double string, nothing. You just declare that you just initiate the variable and declare the value. So that variable will be treated as the data type that you are assigned here. So if you are assigning integer, it will be treated as integer. If you are assigning some Boolean value, it will be treated as a Boolean. So it works like that, right? And so this is like so this is constants. So constants means so what is constant actually?
You can't change the value, right?
Yeah, we can change the value, right? So once it is declared, we cannot change that value, right? So it is fixed. It's kind of a fixed value. So it's like in Java, usually we do something like this: static final int pi. So we can do this one, or else final int pi, right? So if you provide this one, we cannot change. So this pi variable you cannot change. So you cannot, that means you cannot provide a new value to this pi variable. So the compiler will throw another. And if it is C#, we use this const keyword. We use this const keyword, and we use int, and or else we can use this one, read only. So both ways we can do, right? And for C++, we need to add this annotation, right? Hash define pi, or else we can use constraint pi equal to 3.14. But for PHP, so it is something like this, define. So you can see some similarities with the C++ and PHP. So the same keywords, so define, so the keyword name and the value, and also you can use something like this. So that's how we basically treat constants in the languages. And we have these comments, you might know about that one. So in C++ and Java, so you can see everything is same. And in PHP, it is like this. You can provide this or this. And in C# it's like this, and documentation command is something C++ not provide, it does not support documentation command, and PHP as well, but Java and C# it provides documentation. And there are operators like all languages, right? So it has, so including Java and PHP, everything it has this one. So plus, minus, and what is this, multiplication and subtraction, and this is called what is this, reminder, right? Or modulus or something, yeah. So that is arithmetic operators basically, right? These things you might have learned in your first year of a semester or something while studying C or C++. I hope you are familiar with that one, but this will be a touch up for that your previous knowledges, right? And we have these things, and these assignment operators, right? So you know this one, equal, and so if you, so what is the meaning of this one actually? So if I say x plus
x equal x plus 1.
Yeah, okay. So x equal x plus 1, right? So the same applies for these minus and those things. And it has some other operators like PHP has this one and this one. Java has this operator as well. So if we talk about this comparison, right? So all languages supports the basic comparisons like equal and not equal, greater than, less than, greater than or equal, and less than or equal, right? But PHP supports two things. So what is this actually, and what is this actually? Any idea? Why? So okay. So what is the difference between this double equal and the triple equal? Any ideas?
We are checking the data types and the values. Yeah.
Sorry.
In PHP, we are checking data types and values, right?
Yes. So so in PHP, even in JavaScript, this applies the same, right? So in PHP or JavaScript, if we are providing double equal, it means it checks only the value, right? So that means 5 equal 5. So what will be the output for this?
False,
So
0.
this is false, right? So if we are providing triple equal, then sorry, if you are providing double equal, what is the answer? If we are providing double equal, what will be the answer?
So when you provide double or triple, output will be 0, right? Is that wrong?
No. First answer for the first scenario. So let's say, okay, we'll go to something else. But I will open this my browser and I go to this thing. Okay, and so let's say and we have native 15. So what I'm doing is console.log a equal p. So what will be the answer for this? Either true or false.
True.
True. Why is that?
It only checks the value, right?
Yeah, it only checks the value, right? So 15 is
It
here.
didn't check
15
the
is here.
data type.
Yeah, it doesn't checks the data type. So if you are providing double, so let's say A is also 15, B, yeah, it contains a value 15, so it returns true. But if you are using triple equal, right? So now it is false. But actually, this is A and B is not equal, right? So because this is a string value, this is an integer value. Am I correct?
Yeah, sir. Yeah.
Yeah. So to confirm that, we are using triple equal. So what if you are using a triple equal, what happens is it checks the value and also the data type. But if you are using double equal, it checks only the value of the data type. So so that is the difference between what is that? Double equals and
Double equal,
triples. Yeah.
triple equal.
Right, and also this one and sign and O, and this is not right, and all in PHP we can use these things as well. So logical operators, and we have bitwise operators as well, right? So if you are talking about the arrays, when in Java we have this what is that? So we declare arrays something like this, so similar to C# as well. So that is same, right? So, but in C# we have to define something same as this. But in Java we can do it in these two ways. But PHP, that is totally different, right? So it's have uh, something like this, or else we can initiate an array something like this, and also we can initiate an array something like this. So this is called this one is especially called as this type of arrays are called as associative arrays. So associative arrays in the sense it has a key, that means a unique identifier and a value for that key. So same, right? So this will be one set of value, and this will be another set of value. So it has a key value and a unique value. So a key value and a value for that key, right? So this type of arrays, that means the associative arrays is not supported in this languages like Java, C# and C++. But it does not mean like we cannot do the same approach in Java and C#. That means we cannot we can do these things, but we have to do in a separate way. We either need to use like a hash map or hash set or something else, or else some other stuffs. But for plain arrays, we cannot use this associative arrays, right? So those are like arrays, how we can declare them. And if we talk about the if condition, so this everything is like in all languages, it is pretty much same. So the if and else condition is like it is pretty much same. So for all the languages, we can use the same, right? So there is no code differences. But in PHP, we can use something like this and this as well. So this is, you might have seen this one. This is something similar to Python. So the Python expression is something like this. So not else there, it should be else in Python, right? And so switch statement. So that is also pretty much same for all the what do you call languages, right? So there is nothing different, but we can pass several parameters like different type of parameters into the switch statement, and also for the C# as well, both PHP and C#. But for Java and C++, it takes only one parameter. And then we have these loops, right? So so all three languages, like it supports the basic loops like while and do while loop and for loop and all everything, right? And but Java additionally supports thing called another kind of for loop. So this is more likely to be used in an array, right? So if you are traversing through an array, if you are like going each, like checking each and every value from an array, you can use this one. This is some kind of for each loop. This is called as, and also the same implementation is done something like this in C#. So here we use the for keyword, but in C# we use for each keyword, right, instead of this for. And instead of this colon, we use in keyword here, right? And C# it also sorry, C++ it supports the only basic loops like while, do, and for loop. But PHP it has two things as well, addition to these three. So it also supports the while, do, for loop, but this is again to traverse through an array, right? And also this is another method to traverse through an array. So here the differences is like so here you are if you provide this thing as key or something like this, so this key is the one if you are traversing through an array, so the array's key will be starting from 0 to nth position. So this key, so this key variable will denote that your array's key. So that is the difference between this for loop and this for loop. So here in this for loop, you cannot traverse through the using, you cannot get the key value actually, but you can get the values in an array, right? So that is the difference between those for each loops. And we have the main method of all the languages. So we can implement the main method of Java using these three variations. You can provide this one, or this one. It doesn't matter, but in C# we can do this things like this. Static void main and static void mains are pretty much similar to this Java's implementation. And for C++, we have this one. We either can have argumented parameter, or else we can have like, sorry, argumented method, or else we can have a method with no arguments, right? But for PHP, there is no main method. If you run the code and if you execute through a browser, it will work. So there is no need to mention a like main method there. So that is the difference. And yeah, so those are the things that I need to be. Have some other differentiations as well. So each and like if you talk about the classes and methods, right? So you can explore more about that. So in classes there are like there is a set of different implementation when we like do implementation in Java and C# and C++ and all, right? So there are some quite differences, not much like, right? So yeah, that's just like when we compare about those languages, like, and if you took like the next topic will be like OOP. So this will this you most of you might heard, or if you are like still in first year or first semester, this will be new to you. So anyone?
So is this object oriented?
Yes, exactly. So are you all familiar with this one, this concept?
Sir, really, I don't know about this, but I have
Just start
studied this.
Sorry.
We just start studying. So
Okay. Okay. All right. So we'll touch what
So we have
OOP.
studied this, but we don't know the actual concept of object oriented.
Okay, we'll see then.
Okay, sir.
Right. So actually, what course are you following?
BICT.
BICT from which campus? Maunia campus.
No, sir. Southeastern.
Southeastern. Okay. Then okay. Then other one? Open University. Okay. All right. No worries. We'll look into that shortly. So so if we talk about OOP concept, so now like earlier we were talking about this things, right? So object oriented programming. So we mentioned about something called object oriented, right? So this is this thing, object oriented programming. So basically, as I mentioned before, in the procedural languages, procedural programming languages, right? So in the initial state, what happens was all the codes that we are writing was functions. So it will be like executed from top to bottom. So there will be some functions. We are calling the functions and it will get executed, right? So one by one, it will be get executed. So laterly, they understood that. So if you follow this paradigm or this pattern, there is more likely like we are like duplicating the codes again and again, right? So that is the basic concept. So we are duplicating the codes again and again when we are trying to use procedural programming, right? So what happened was they introduced a paradigm, they introduced a methodology to avoid that one, right? So to avoid that one, so they can get rid of this code duplication, and also they can introduce code reusability, right? So once the code is defined somewhere and we can reuse that. So that's where this OOP concept came out of. Sorry, right? So basically this OOP, that means this object oriented programming, reflects the real world scenarios, right? So what happens is we are mapping our program along with some real world objects, along with some real world entities. For example, we can say a car, a house, or employee, a person. So what happens is we are getting rid of the functions and we are depending on the objects. So these are the objects like what is that? Animal and cat. Let's say if you're talking about animal, so cat is an animal and dog is an animal. But the what do you call it? The cat is a type of animal and dog is also a type of animal, right? So likewise, we talk about the objects in object-oriented programming. So the first concept, right? So this is called like 4 pillars of OOP, right? So we have four concepts, so four basic concepts, which is encapsulation, abstraction, inheritance, and polymorphism. But to understand this one, we need to be clear about two other what do you call topics, which is objects and classes, right? So if we talk about these objects, so objects are always called an instances of a class. So let's say now if you see this one, right? So now this fan is an object and this table is another object and this pen is another object and this keyboard is another object and this what is this motorbike, it is another object. So these objects are pretty much similar to our real world things, right? So these objects will include two things. One is their state and their behavior. So two things. One is state and their behavior. Right. For example, if we take object as, let's say, a person, right? Person. So if we take this one as an object, so can you tell me what are other states this person can have? State in the sense, what are the features this person can have? What are the features?
Features means what you asking, sir?
Okay, if okay, assume that there is a person called A, right? So for a person
Okay.
like what he will have eyes, right? Legs,
Yeah,
right?
eyes, nose,
Right.
hands,
So there will
legs,
be like a number of
fingers.
eyes and number of legs. Likewise, it will be like having so many features, right? Am I correct? So
Yeah, sir.
these things, like those are the common things, right? So there will be some exceptional persons who has like let's say there will be, you might have seen like a person who is having 6 fingers on a hand or 6 fingers on leg, right? So that is exceptional case. But if we talk about a person commonly, a person will have 2 hands and those each hand will have 5 fingers, right? Isn't it?
Yeah, sir.
Yeah. So those are the common features, or else we can say in other words, those are the attributes. So a person will have 2 eyes and he will have like 1 nose, right? So those are the states. So eyes and mouth and nose, hands, number of fingers, those are the states or attributes or features, whatever. And we have another thing called behavior. How a person will behave. He can walk, right? He can run,
He can talk.
he can talk, he can sleep, he can jump, he can fly. No, right? That is not a feature of a person, right? It is a feature of something, right? So those are the features of a person, right? So out of this person, let's say this is a object, right? So out of this person object, we can create some other object as well that we'll talk later, right? So, but for the moment, let's say if a person, there will be two things, which is state and behavior. So basically, this is called object. So this object is kind of a real world thing, what we can notice, right? For example, you can see this one as well. Animals as object. If we treat animals as object, it has states like color, name, breed, and behaviors such eating, wagging the tail, right? Something like that. So that is object. But if we are talking about the class, right? Classes is kind of a blueprint. So basically a blueprint. Now let's say you want to build a house, right? If you are trying to build a house. So what will be the first thing that you will do?
We'll give a map, right?
Yeah, we need to meet a engineer or draftsman or like some other person who is doing architecture, right? We'll meet him and get a map of the house, right? So that is the first step. So that map is called as blueprint. You know about that, I think. So that is usually called as a blueprint, right? So assume now you have the blueprint. You have the blueprint in your hand, right? So using this blueprint, you are started working to build the new house. This is the house. You build the house. So this is the blueprint. right? So now you have built this house successfully. So after building this house, using this blueprint, you will the house.
What, sir?
Sorry.
We didn't hear you, sir.
Okay. So now you have the blueprint, and using this blueprint, let's say within 4 months or something else, you have successfully built this house. Are you clear about that?
Yeah, sir.
So now this house is built successfully after 4 months, right? So now you have the blueprint, still you have the blueprint in your hand. So if that is the case, are you able to build another house using that blueprint?
No, sir.
Why is that?
Because we already built that house, right?
Yeah, we already built that house. That
But
you already,
actually, we can build a house with that blueprint.
yeah, that's my question. So are you like okay,
Yeah, we
like
can build
using
it.
the blueprint? Okay, let's assume something like that, something like this. Okay, now you might have seen this what do you call, housing plans, right? Housing plans. What do you mean by, for like let's say these tsunami affected peoples and war affected peoples, the government has like provided homes and those things? Are you aware of that one?
Yeah, sir. Yeah.
Yeah, okay. So have you ever visited that place and have you noticed how that houses are built?
No, sir.
Right, okay. If like is there any person who has noticed? Is there anyone? Okay, so it's real one. Okay, real one. Then now can you tell me like those houses, like let's say there is 100 houses in a housing plan who was affected with this tsunami waves, right? So there are like 100 houses. Can you tell me like is that house is same as each and everything? The infrastructure same, right? So let's say there will be one bedroom and there will be one hall. Everything is same. So if you in any housing plan, if you go and visit, right, the common thing there is like all the houses. Let's say if there is 100 house, all 100 houses like look same. Only the position of the house is like different. One house will be like next to the road, and other house will be like far from the road. So that is the difference. But the infrastructure of the each and every house is that is the same thing, right? Am I correct? Yeah, okay. So if that is the case, do we need to like build like 100 blueprints for 100 houses? No need, right?
No, sir.
Only one blueprint is enough. Yeah, only one blueprint is enough, right? So now we'll come to our topic. So blueprints and houses. So these blueprints is our class. These houses are our objects. Are you clear now?
Yeah, sir.
Right? So we define class at once
In a
and we create objects,
in
many
a class, we
objects.
can have so many objects, right, sir?
Yes, out of a class, we can have so many objects. So that is where the OOP concept comes in. So this class will act as a blueprint, and out of this class, we can create multiple objects. So if that's the case, we can create a class for this fan, and out of that fan class, we can create multiple fans out of it, right? So if we are providing these states and behaviors for that particular class, for example, now this blueprint is a class. So now this blueprint will have number of bedrooms, dining room, right? And number of holes and number of what do you call it? Some other things, states, and also it has some behaviors, right? So out of this blueprint, we can create 100 houses. So each and every house will get the same state and behavior which this blueprint initially got. Are you clear about that?
Yeah, clear.
Right. So that is the concept of objects and classes, right? So classes are like object constructors for creating objects. So as I mentioned before, those are the constructors. So those are the blueprints. So out of these classes, we are creating objects. So the collection of object is said to be a class. So the collection of object is said to be a class. Normally, we can say it as a blueprint. Classes are said to be logical quantities. Classes don't consume any space in the memory. So that is a good point. It doesn't consume any space in the memory, but the object does. Class is also called a template of an object. So another word, blueprint, template, whatever. Right? So classes have members which can be fields, methods, and constructors. Now this state will be mapped into these fields, and these methods will be the behaviors, right? So that's the thing. So we have a class and we have a methods. So let's see how we can declare something. For example, now we'll come here and let's say I'll close this everything. I'm a pretty Java related person, whatever. Okay, so I will create some class, something called this. So how we are creating class, something like this. So this is based on Java, right? So it might differ to other languages. So let's say a person. So we have a person class here. So we have the fields. What are the fields? Like integer or integer, string name, string address, right? And we have other thing called a constructor, public post. So this is called a constructor, so empty constructor. And also we can have overloaded constructor like this, right? So let's say we are passing two parameters like name, string address here, and we can equal this one, this dot name equal to this parameter, the name parameter name, right? And this address, this address. So this is called an empty constructor, and this is like a parameterized constructor with parameter constructor. So right. So this is the basically, this is how basically we declare a class in Java. So we have this one, right? So out of this class, what we can do is in so for example, somewhere else. So out of this class, we can have objects like what is that? So person one equal to new person. Right? So we can have the name as Tony Stark, California. Right. Some message. And we can create another object out of Charlie. Something like this. So we can see now this person is kind of a blueprint, right? We have the template here. Out of this template, we are creating two objects. So I have just created two objects. You can create number of objects out of this person class, right? So that is called objects and classes. Understood? Any clarifications or questions? You can anytime
sir, understood.
distract me.
Yep.
Right. So yeah, don't worry. You can distract me anytime. Right. So we'll move on to our topic. So those things are the basics like objects and classes. And if we talk about so now we'll come to these four pillars of OOPs. So first one is encapsulation. So the very first paradigm is encapsulation. So encapsulation, what we do is, so basically this is how they are calling it. So it is a process of wrapping code and data together into a single unit, right? So it is a process of wrapping code and data together into a single unit. So that means we do something inside something and wrapping that one and providing to the developer or the person who are writing the code, right? So we'll see how we can implement this encapsulation as well. So we can create a fully encapsulated class by making all the data members of the class private. Now we can use setter and getter methods to set and get the data, right? It is a way to achieve data hiding. So you need to emphasize this as well. So two things, wrapping code and data together into single unit, and also, right? This one, and also data hiding, right? So we can hide some data using encapsulations as well, because other class will not be able to access the data through the private data members. So the encapsulate class is easy to test. So it is better for unit testing. So when we are testing our code, if we encapsulate, that means if we wrap our code and data together into a single unit, if any errors or any exceptions occurs during our runtime or compile time, when we are compiling our program, so what we can do is we can go to that single unit, right, and check whether everything is okay, whether is there any wrong in our code. So that is basically called encapsulation. So I will explain the code again, right? So now let's jump into this code. So let's say I have two things. So I have a class called student, right? So are you visible to this screen?
Yes, sir, it's visible.
Yeah, sir, we can see, sir.
Okay, right. So now this is a class, right? So this class has two data members, which is private. So before that, have you heard about private, public, protected? Have you heard about this one?
What about private and public?
Okay, we'll talk about this. So we'll talk about private first. So that is the encapsulation comes, how the encapsulation is working. So now, so we said that earlier. It is about code and data together into a single unit and data hiding, right? So now let's say this student class should be accessed from this main method, right? I will comment this one, or I will just delete this one. So from this main method, I need to access this student class. This student class. So how I can access that one? Student as equal to new student. Is it correct?
Yeah.
Okay. So now in the student, we have these data members, right? What are the data members here? Name and age. We have name and age. So let's say now we are putting this as public. So from this one, from this S object, I can directly access this age and name. So I can set age like 15 or something. And S dot name equal to star. Right? So encapsulation is avoiding this process. We should not allow others to modify this class directly using this data members or something. Are you clear about that? Understood, or shall I repeat again?
So one second.
Sorry,
1 second.
I couldn't hear you. Your voice is breaking. Okay, so encapsulation is something. Now we have these two data members. We should not allow other members out of this class to modify this data directly. Are you clear about it?
Yeah, sir.
Yeah.
So now what happening here? We are modifying the data member. We are directly modifying the data member. Right?
When you give public, we can directly get
Yes.
that, sir. Right, sir?
Yes. Yeah. If it is public, then we can
We
directly
can access when you put public, right?
yeah, wherever from our code we can access that one if we are making it as public, right?
Yeah.
So our approach is like we need to hide the data and we only need to provide the relevant thing. So that's why we are making it as private, right? So now it says one related problem. If we go here, it will show. So age has a private access. So this is not now available out of this student class, but you can access this one inside this class. Are you clear about that? So that's how we are accessing this one, right? Out of this class we cannot access. So the only way to modify this data member is to use these functions, this setter function and the getter function. So setter function is to set or modify the data. Getter function is to get the data. Clear?
Yeah, sir. Clear.
So now for this student, so we can use this set name function and we can pass the name, and for the set age also we can pass this 55, right? So this is what encapsulation is. So we are limiting the access inside, like we are limiting the process inside this class. So the only way to modify these things is to use a function, use a set a function or a get a function. So now from this one, if it is a public variable early, if it is like something, so if you come here, so if you make this as public, and if you come here and if you put a system dot out dot println and s dot age, so now you are directly accessing that. So you are directly accessing that one because it's public. So we are avoiding this one and we are making it as private, and we are using the get age function to get the actual age. Are you clear about this?
Yeah, sir.
Right? So here, like it is not only about like wrapping code and data together and data hiding, but what we can do is actually we can do something like this as well, right? So this is also actual encapsulation. So we are not exposing what is happening actually inside the function. So now you can say, can a person have age in a minus value? Is that possible? Let's say minus 15. Can a person have something like this?
No, sir. It's not possible.
It is not possible. So let's say if that is the case, so in this set age function, what we are doing is we are wrapping the code inside that one, and we are checking this one, right? Age is greater than 0 only, we are assigning the age, or else we are setting it simply as 0. So this is another kind of encapsulation. So this is another kind of encapsulation. So to the person who is accessing this class, so if some developer is working on this one, or if someone is calling this function from somewhere else, right? He actually don't know what is the logic behind this set age, right? He only know the function. So he just pass this value, and if the value is greater than 0, the age will be updated, or else it will be remain as 0, right? So that is the logic. So encapsulation is basically we have wrapped the code here into this single class, right? And also we have hide the data and its implementation to outside world. So this is basically encapsulation. Clear now?
Yeah, sir. It's clear.
Right. So we'll move to the next one, abstraction, right? So abstraction. So now I will explain what it is like. So basically, abstraction is kind of hiding the implementation details and showing only the functionality to the user. So that means, let's say, now you are working on a laptop, right? So what are the things that you can notice on a laptop? There's a keyboard, and there is a display screen, LED screen, and there is a trackpad, right? There is a USB port, and there's a headphone jack. So there are some features out of there, and it has its own functionalities, right? So now you are turning on a laptop, or you are like typing something else, right? So that is the functionality that you are doing as a user. Am I correct?
Yes.
Yeah.
Yeah, sir.
So in order to work with a laptop, do you really want to worry about how this trackpad is actually working, how this mouse pointer is going there and here, how this key is being pressed, and how this letter is being, how this is working, how the process is processing the data? Do you really want to care about that one?
No, sir, we don't care.
No, right? No, right?
Yeah.
Unless you are a techie person, right? If you take about like a general audience who like use computer in an office or something else, or let's say in DS office or something else, or in school or typist or something else, he doesn't want to bother about what is happening inside, right? He just use the functionality provided to him. So that is basically abstraction. We don't need to worry about what is the implementation is about. We just, if you want to type, okay, you can press the button and you can type. You don't want to worry about how it is being typed, how this letter is being generated, how this process is being done. We don't need to worry about that one. So that is basically a real world example of abstraction. And I have provided another one thing here, right? So you can read that this as well. So it's another way, it shows only essential things to the user and hides the internal details. For example, if you are sending SMS, you only worry about the text and the number. You don't worry about the message, like the how this text is passing to the number, how this is going to the telecommunication, and how this is going to the telecom, and how it is getting transferred. We never want to bother about that. Got it? So that is basically abstraction. We only focus on the functionality, not about the implementation. We don't know, we don't even know to worry about that. So the same thing applies in our OP as well, right? So we'll jump into the code and we'll see how we can achieve that one in our scenario. What is about abstraction? So now let's say I have a class called car. So basically in Java we can achieve abstractions in two ways. Create abstract classes, and we can create interfaces, right? Two things: we can create abstract classes and we can create interfaces, right? So we'll see how we can create abstract class. So first of all, so abstract class, that we declare something like this. So abstract, we need to use this abstract keyword, right? We need to use this abstract keyword, and we are using this abstract void run. So for example, I'm creating class and it has a function, abstract function as a run. So this is our very first abstract class. Someone has a message. Okay. And out of this abstract class, I have created another class called Honda. For now you can see, so this Honda class is extended from this car class. So that means, so now here we have this run function, right? And the implementation of this run function we have here.
So what's that extend car?
Yeah.
Honda extends car. What's that mean?
Extend car means, yeah, that is another what do you call it? Okay, I will come to that and I will come to this back.
So Honda is the class here, right?
Yeah, Honda is a class.
Then what's the car?
Yeah, that is also another class. There, yeah, I will explain that one and come. So I'll hold this abstraction part now, and I will come to this concept, inheritance. Right. So inheritance is a mechanism in which one object acquires all properties and behaviors of a parent object. So that is one. So now let's say, so our previous example, let's say, or a new example, we'll take something called as animal, right? So out of this animal, we can create things like, what is that? Dog, and this thing, we can create cat. And other animal we can create like elephant. Right. So this animal has some separate features like number of eyes and number of legs and number of tails, something like that. And but if you talk about let's say what are the special features for dog, what will be the special features? Okay,
4 legs.
it has 4 legs. All the animals has 4 legs. Yeah.
Special feature.
Yeah. We'll say something. What is that? Something like okay, ear shape or something. Ear shape,
Okay.
right? Ear shape. So the ear shape of dog, cat, and elephant, is it same?
No.
No, right? So this is different, and this is different, and this is different. So what we do is we create a parent class. So this is the parent class, animal class. This animal class will have the common behaviors and common states for all the animals. Are you understand about that? Are you clear about that? Okay. So out of this parent class, we will create subclasses which will have their own set of features like ear shape and something else. So this dog's ear shape is different than this cat, and it is different than this elephant. Is it okay now?
Yes.
So that is what inheritance is. So what happens is from the parent class, we are inheriting a subclass. So now what happens is this dog will get all the properties of this animal. So like number of legs, number of eyes, number of mouth, something else. Addition to that, it will get this feature as well. Clear? I clear that?
Yes.
So,
sir, yeah.
right? So that is basically inheritances. So now for the cat, it has its own set of features. In addition to that, it will get all the what do you call behaviors and states of this cat. Same applies for elephant as well, right? So that is basically it is also called as ISA relationship or else ISA hierarchy. It is basically a parent-child relationship. So if there is a child, so for the child there will be some set of unique features, and also from the parent there will be some features derived from the parent, right? So that is basically inheritance, and we have 3 kind of inheritance basically. So let's say class B and class A. So the all the features from the class B will be inherited from class A. Sorry, all the features from class will be B will be applied to class A as well. So this is called single inheritance. This is called multi-level inheritance. So class C, and out of that we are creating class B, out of that we are creating class A, right? So if we take the example, okay, animal, dog, and we can say male dog, female dog, something else, right? Something like this. And this one is like hierarchical. So out of this one, we are creating another 2 things. So these are 3 type of inheritance applied in our modern programming language. So that is what it's here. So if we focus on this one, this is what. So car is a parent class, and out of that class, we have created Honda, right? So that's where we are using this extends keyword. So car is a parent class and Honda is a child class. I'm clear about that now.
Yes.
Right. So since we have made this as abstract class, right? So if we go to our main method, so what happens is now let's say I will clear this one. We don't need this anymore. And we come to this encapsulation. Are we talking about encapsulation or abstraction? What are we talking? Abstraction. Right? So now we can see this is also abstract. Right. So here now we can see I have created a car object, right? This is a car object, and we using the car object I have initiated Honda because Honda is a subclass of this car. So in that case, what we can do is we can use something like this. So we can create car objects out of Honda, right? Then what I'm doing is in this car object, I'm accessing this run method. So if you go to this run method, now you can see only the function is there, not the implementation. You see that one. So only the function is here, right? Not the implementation. Can you see this one?
Yes.
So what we are doing is actually we are hiding the implementation to this one. So if someone wants to, like, if we traverse through this function, okay, yeah, you might notice that, okay, only the function is there, the implementation is not available, right? So implementation is we are overriding and doing it in the Honda class. So now what we can see. So if we want to create another car object out of object 2 out of right object 2.run. So in the run function, we don't have the actual implementation. We have only the functionality. So this is same as now we have the keyboard here. We are pressing a key. So that is this function, right? So what actually happens when we press the key, that is being implemented in this here, in this function, in this class. So if we run this one, so basically if we run this one, I will comment this out. And this thing as well. And if we run this, so it's building. Right, so it says running safely. So where this running safely is coming from, you can see, okay, this is only the function is there, but the implementation is available in this box, right? So if a person is trying to access this one directly, they cannot see the implementation, what's actually inside there, only the function is. So this is what abstraction is. I'm clear about that.
Yeah, sir, clear.
Yeah.
Okay. So so as I mentioned before, we can do the abstraction in two levels. One is we can use abstract classes as we have done now, right? The second method is we can use interfaces. So interfaces I will explain that one. So now we are creating an interface here. For example, so here we are doing it as abstract class, but here we declare it as interface. So interface is a kind of special class which has only the functions, not their implementations, right? So let's say now it has a public interface A. It has these 4 methods. These 4 methods, and these interface should be implemented in a class. Now let's say this one is implemented in a class called B. So it's an abstract class. So this does not need to be an abstract class. Actually, we can put it as a class as well, right? It doesn't matter, right? So so this for now earlier, if we are using extended classes, we use the keyword called extend, but if we are using interfaces, we need to use the keyword called implements in Java, right? So here again, we have this class B, which implements A. So that means this class B should implement all the methods A, but for the method C, method C inside this A, what we have done is we have override it in the class B itself. So now we have override it here, right? So again, what we can do is we can extend this class B into class M. So now you can see public class M extends B, right? Since we already extended this class here, if we want, we can extend it here, but in this case, I did not extend that one. What I have done is I have extended A, B, D from here, right? A, B, D from here. But this method is actually coming from this interface A, because this is something like this. This is something like this. So B is there. This is extended with M, right? And it has an implementation of the class A. It's implementation of it. Since this class, this abstract class, implements this interface, it has all the methods here. It has all the methods of interface A here. Since we are extending this class with B, again, it has all the methods here. So that's what happened in this scenario. So that's what happened here, right? So extends. So, but if we want, we don't need to do. If you want, we can just copy this one, cut this one, and we can paste it here. So that is not an issue, right? So we can access this one here. So now we are creating a object out of this A interface and implementing this M. So out of this A, we can get all the methods. So if we visit this A.A, it will directly come here. So now we have only the function is there. Function is there, not the implementation. So if we run this one, so all the four methods will be accessed successfully. Like I'm A, I'm B, I'm C, I'm D, right? So this one is getting implemented here, but actually we don't know what the implementation is. So here it's here. So that is another type of abstractions. Is it okay? Are you clear about that?
Yeah, sir.
All right. So so the next we talk about the inheritance. So the next one is polymorphism, right? So polymorphism is like what is this thing is called, we perform a single action in different ways, right? So basically what happens is in polymorphism, there will be a function which will be accessed in many places, but it will be having its own implementations. For example, let's say animal, for example, a class called animal. as an attribute, a function called make sound or something. And so speak something, speak, right? So we have subclasses like dog, cat, and what is that? Dog, cat, and so cow. Okay. So now let's assume this animal, all the animals can speak, right? In that case, if a dog want to speak, how it can be, how it can speak? What is the sound it's going to provide? Simply barking or something, right?
Yeah.
So same as cow will provide some noise, and cat will provide some noise. Is it okay?
Yeah.
So there are different noises. What we are doing is we are getting this method inside these subclasses, and we are doing the own implementations. For dog, it will be the different implementation. For cat, it will another different implementation, and for cow, it will be another different implementation. So for dog, it will be barking. For cat, it will be like, I don't know, meow or something. For cow, it's like meow or something, right? So for this one, it is like bow. So that's how it speaks. So this implementation differs from this, and this implementation differs from this. So we define one single action and perform it in different ways. So that is what polymorphism is about. Polymorphism is like we can do in, it has another two concepts called method overloading and method overriding. We heard about that one, method overloading and method overriding. Anyone? Yes or no? Okay. So I will explain what is method overloading and method overriding. So now let's say I have a class called shape. So this is the parent class, right? What happens is I have a function called area. So a shape can be any shape, right? So we are passing two parameters, which is length and width. Are you clear about this class? There's only one function, which is area. I'm returning 0, just 0, I'm returning 0. Are you clear about this one?
Yes.
So I have another class called rectangle, right? Where I am extending the shape. Now what happens? So now what happens? So we have shape and extending that one with is this rectangle, and it has area. So this area is now accessible with this rectangle, right? That is the inheritance basically. Are you clear about that?
Yes.
Right. So since during this because of the inheritance, this area is accessible now. So this area, what we do is we override this area method and we do our own implementation there, like this. So this shape just return 0. Override this one here, and I return the multiplication of length and width. I play with this. So in order to calculate the area of a rectangle, what is the equation? It's like just a length into width, right? Right. So again, using this shape class, I'm creating another subclass called triangle. In that triangle, what I'm doing is I'm again overwriting the area and I am returning this one. So for calculating triangle, it's like, what is that? Base, width and length divided by 2, half into length into width, right? So that is the equation. So I'm just returning this one. So now we can see this one, right? This one is written in different formats. That is called overriding. So overriding means same functionality, but the implementation inside the functionality is different. Are you clear about that?
Yes. According to which we can implement that one.
Yes. So same function, name and same function, same parameters and everything, but the implementation inside the method is different. So that is called override.
So
Yeah.
for that one, for one main class, we can override many things.
Sorry.
According to for one main class,
Yeah.
we have to override our which according to our needs.
Yes. So in the main class, it's like this, right? So it's something like this. So we are creating a shape R, which is a rectangle, and we are creating shape T, which is a triangle. So the rectangle area of, if we are accessing this R methods area passing 45 and 2, then it should calculate this one. It should go on. So now since it is a rectangle one, it should get override by this method, right? And for shape T, since it is a triangle, if you are accessing T dot area, then it should come here and it should calculate this one. So if we try to run this one, so what is the output? Right. So the rectangle area is 900 and the triangle area is 45. So the first one is accessing here, so length into width, and the second one is accessing this one. So length into width divided by 2, which is 95. Sorry, 41. Clear about that?
Yes.
Right. So the next one we have, the concept is called overloading. So overloading is something else. We are having, so earlier overriding means same parameter numbers, same parameter types, same return types, but the implementation is different. Overloading means, right, same, what is this? Function with different parameters or different type of parameters. So now we can, so now from this one, we can create another object like shape R2 equal to new rectangle. Now in R2, we can see area rectangle area. So area, right? So we can have, where are we? Yeah, we can have this one, this area as well. So in this case, we need to pass only one parameter. So if we are accessing this method, we have to pass only 2 parameters in this sense. So those are 2 concepts like overloading and overriding. So overloading is we are implementing the same method in different ways. Overloading means we have different parameter types for the same function. Right? Are you clear about that?
Yes.
Right. So those are the basic concept of polymorphism, and that concludes the OOP. And we have another small section which is databases. So I think you might know, right? So databases is kind of organized collection of data which we can generally store data in the systems. Like it's an organization of for storing and managing and retrieving information, right? So these are like some type of databases. We have distributed NoSQL database, cloud databases, and relational databases, network, object-oriented, hierarchical databases. So these are some kind of databases, but mostly used databases is like relational databases. You might heard about this, right? So we use like SQL queries in order to store and create data and retrieve data and update data, delete data from databases. So in relational databases, all the data will be stored in a table format. So for each and every table, it will have its own columns and rows and all. So it will be having like that. So the very famous relational databases are like MySQL server and Microsoft SQL server, Oracle databases, and PostgreSQL and IBM DB2. There are so many relational databases as well, and also NoSQL databases. So this is quite becoming huge among these days because of this big data, artificial intelligence, and those kind of things. So here, so like we use SQL here in order to query this one, to create and update those kind of things. We use a language called SQL, right? But in NoSQL databases, we don't use any SQL syntax, but that doesn't mean SQL syntaxes or SQL codes are not supported here, but it is not limited to SQL, right? We can use some other mechanisms as well. And also we can divide NoSQL databases like document-oriented and wide column graph databases and Q-value storages. And so those are basically 4 different NoSQL databases types. So for example, there are like MongoDB is like mostly used databases. It is like most used now, and GraphQL, Couchbase, CouchDB, and Apache Cassandra. So everything is being categorized as NoSQL databases. And also we have cloud databases. So now in the current era, in 2021, right? So we have thing called cloud. We have AWS, we have Azure, we have Google Cloud Platform, and we have Alibaba Platform. So there are so many cloud providers, right? So each of them provides their own set of databases, which is called as SaaS providers. So software as a service. So those databases are like Azure SQL databases, I mentioned RDS and Oracle Autonomous Database. Likewise, each and every cloud provider provide their separate cloud databases to the end users. And hierarchical databases, this is often like Windows file registry, right? You can see so something like this. So this is like if you go to my computer, so my computer is the parent one, and if you go to D, so that is the sub one, and there are like so many folders. So that is called a hierarchical database. So simply it is like one-to-many kind of a thing. So there will be parent and there will be many children, and each children will be having children likewise, right? So that is a registry and IBM information management system and all. And we have object-oriented databases, same as like our object-oriented programming languages. We have object-oriented databases where we treat objects and classes. There we can create classes and we can create objects out of it, and we can store it in our like database management systems. So that is called object-oriented databases, which we need to, which is managed by object-oriented database management systems. So for example, there is Wakanda, not King T'Challa's Wakanda. This is database Wakanda. So we have object store as well here, right? So those are some kind of object-oriented databases available, and you can also search for more. And yeah, so that is for the topic today that we have covered. So we have pretty much covered about programming and comparison between programming languages like C++, C#, Java, and Python, sorry, PHP. and we talk about the OOP concepts, and finally we gave an introduction about these databases and the type of databases that you can explore in detail further in the future, right? Any questions or any clarifications about this session? Hello, I
Yes,
could
sir.
not hear you.
Guys, if you have any questions, you can put it in the chat box or you can talk to us.
Yes, you can talk to us or you can put it in the chat box. And by the way, please put your comments as well. If you are okay. And your questions and yeah.
Very useful session for us. Very much useful. We are waiting for a future session also like this. It's very much important for our study purpose.
Yeah, that was a great compliment. So any others who has clarifications or doubts or something else you want to be clarified before we winding up this session?
It's possible to have percentage slide.
Yeah, I will provide this to my team. They will forward it to you if possible.
Thank you. Thank you.
Guys, we will get the recorded session in YouTube. We will upload it soon as possible, and we will send the link as well. And there is a form available in the chat box. Please fill it and give us your feedbacks, and
Yeah.
also send us your email so we can inform you upcoming events, a program like this. So we have a plan to conduct a series of event like this program. So please fill the form, and you can reach us. Using our website. It's still in under construction, so there is a Facebook and LinkedIn links available, so you can reach us using those links and keep in touch with us, guys. So we will see you guys on another session since you don't have any questions.
Yeah, and thank you for participation to this session, and hope you enjoy the session as well. And be safe.
Thank you, sir.